In this section, we're going to be looking at measures of variation. Now, these are a critical component of being able to make sense of the measures of center. So the measure of center, usually we're working with the mean, and now we're looking at measures of variation around that mean. We've got three different ways of looking at this that we're going to cover. Range, the standard deviation, and range rule of thumb. So let's work through these with our sample data here for some dogs in my neighborhood. Alright, keep in mind as we move forward that the rounding rule here for variation is that we need to carry one more decimal place than that is present in the original data set. Again, you must make sure you're having this within your formulas. Don't have it separate from, but put it with your formulas. This is the final step, and it will cause you to lose points on both the homework and the exam if you're not rounding correctly. Alright, the first one we're going to look at is the range. It's pretty straightforward. It's the difference between the maximum data value and the minimum data value. So looking at our data set here, we take our maximum data value, subtract our minimum data value, and that's going to give us our range. So take a moment and work through that yourself, and then when you've got your answer, let's move on to the next slide and check it together. Alright, so you should have had 858, that's our largest dog, and then the smallest dog, the shortest dog would be 170, and so subtracting those, we get 688 as our range for this particular data set. Now again, notice the range is always unique to each data set. You have to calculate it each time. Alright, the next we're going to look at is standard deviation, and we're going to be using standard deviation a lot, so you need to make sure that you are clear in the process and mechanisms of calculating a standard deviation and how you use it. We'll be seeing this again and again across the semester. So, a standard deviation measures how much of the data values deviate from the mean. So it's looking at how much do each data point value deviate from the mean and getting an overall assessment of that. That is the goal for looking at a standard deviation. Now, keep in mind, the larger the standard deviation, the greater the distance of the data from the mean. So here we can see with the red distribution, with a standard deviation of 10 and a mean of 50, we can see that the mean, marked here in the dotted red line, we can see there's quite a spread of data values around the mean. Notice that that is different from the blue distribution, which also is a mean of 50, but has a standard deviation of 5. So, when we're looking at this, the larger our standard deviation, and thus the wider the spread of the data around the mean, the less accurate our mean is for predicting future values. And remember, this is again the goal of statistics. We want to be able to make predictions for the future. Those predictions are usually based upon the mean. So if the mean is not an accurate representation of the data values, it's also not going to give me a very accurate representation of data values for the future. So when we're looking at this, we need to look at the variation determines to a certain degree the accuracy of the estimates that we make. So if we're looking at this distribution here, think about which one would allow you to make a more accurate prediction of a score, the one with the standard deviation of 10 or the standard deviation of 5. It would in fact be the standard deviation of 5. As we were just talking about, here we can see that the spread around the mean is smaller. So using the mean as a predictor is going to make me more likely to have an accurate estimate for the future. Okay, so now that we understand why we need our standard deviation and how it interacts with our mean, we need to figure out how to calculate the standard deviation. And here's our formula for calculating the standard deviation. Let's go through and take a look at it together. So, again, with a new formula, let's break it down into the different parts we know. So what do we know are parts of this formula? Take a few moments and identify for yourself what are the different pieces that go into this formula. Well, we know that n is a sample size. Okay, so in this case it's going to be 6. We know that the x represents the height of each individual dog, so we're going to have several x's, right? And then we know that x bar is the mean height of all the dogs in the sample. Keep in mind, we also know when we're looking at our value that we're going to sum all of our scores and our values in terms of squaring them and then taking a square root. So let's take a look at this a little bit further. Keep in mind, when you apply your order of operations, you're first going to subtract the mean from each data value separately. You're then going to square each of those resulting values, and then you're going to sum the total of all those squared values. So we have 3 steps we're going to go through here in order to get the information to go in the top part of our formula. All right, so here we have this. Here's our dog heights. Here's the first row that we have in our chart for calculating what our standard deviation is going to be. So I've got my sum of x there at the bottom. And the next thing I need to move on to doing my formula is my x bar, so my mean. So looking at what we had from our last section, here's my x bar, which is just my sum of x divided by n. Apply my rounding rule, I get 471.3. So we're going to take 471.3, and we're going to take that and subtract it from 600 for our first dog height. That's going to give us a value of 128.7. Okay, so that is the value of x minus x bar for the dog with a height of 600. Now, take a few moments, draw this chart off yourself, and then go through and repeat these calculations for each value. So for example, the next dog with a height of 470 is going to be 470 minus 471.3. So go through and calculate all those, pause the video while you work through it, and then when you've got that completed, turn the video on, and let's check the next step together. All right, so you should have got these values here on the left coming down in the orange. And now we're ready for the next step, which is squaring these values, all right, heading towards being able to sum them all up there at the bottom. So the square value of 128.7 is going to be 16563.69, all right? So the next thing you're going to do is take each of these values that we have. So for example, the next one, you're going to take negative 1.3 and square it and enter that in the next column. Now, let's take a few moments here. Now, notice if we sum up all the values in our row of x minus x bar, we get a value that's really close to 0. All right, that's not going to be helpful because anything that you're multiplying by 0 or dividing by 0 or using it for other calculations tends to cancel pretty much everything out. So that's not useful for us. What we do know when we're looking at something is we want to understand the magnitude, right? So here let's look at the difference. Remember, that's what we're looking at between each value and the mean. So here we see, for example, using the data value point of 300, the difference from that and the mean is negative 171.3 from the chart you just did. And the distance of the data value point 858 from the mean is going to be 386.7. Okay, again, from the chart that you just made. Now, keep in mind, what we want to know here when we're looking at standard deviation is the magnitude of the difference between each data point and the mean. We are not concerned at this point with the direction, so we don't care whether the values are positive or negative. We just care how far away they are from the mean. That is the only point we are focusing on right now with our standard deviation. So, in order to get something that's the absolute, we would take the absolute value here. So you can see here I've gone through and calculated. If I took the absolute value of 470, the absolute value of 430, notice that this cancels out the positives and negatives. And notice the magnitude of the distance remains the same. Okay? However, we cannot take an absolute value of the calculator when doing our calculations. So instead, we're going to use the mathematical equivalent, which is to first square the differences. And then we're going to later remove this effect by taking the square root. In fact, it's going to be the very last step in solving this formula. So we're going to square them. And when we square them, it's going to drop off the values of positive and negative, but it maintains the magnitude of the difference. Okay? And then when we're all done, we're going to take the square root, and that'll get us, that'll correct for the squaring that we're engaging in now. So let's take a look at that. So you should go through and have your chart filled out. That should look just like this. And now that we're looking at it, we're actually almost finished. So again, when you're doing these calculations, plugging the final numbers into the formula, you're almost there. It's going across the chart and computing each of them that's the most time consuming. So here we go. Notice, by the way, we're going to take the square root here. So thus we're completing that mathematical calculations to maintain the magnitude. Okay, so that's going to be the last step. So going across, we can see here we have plugging in our numbers and working our way across. And we get, with our rounding rule again, we get 240 as our standard deviation for this particular sample set. All right, so that is our standard deviation for this particular set of data about the heights of dogs in the neighborhood. make sure that you understand why we are squaring and then taking the square root again. So that is a concept you need to understand to be able to work with this data. Now, the next parts we're going to look at is range rule of thumb. So the range rule of thumb, we have two components here. One, we're interpreting a known value of the standard deviation and determining if it's a usual or unusual. And then the next thing we're going to look at is estimating a value of the standard deviation. So when we're looking at interpreting, we're going to apply the value of a minimum usual value and a maximum usual value. And to calculating these boundaries for the particular data set, we use the formula here. So we've got x bar minus 2 times the standard deviation for our minimum and x bar plus 2 times the standard deviation for our maximum. Now this formula is slightly different than how your book presents it. I think that your book makes it a little bit confusing in your order of operations. So I suggest you write down the representation that I have here. It gives you the same amount, but I think it's a little less confusing. So let's work through these together. All right, so we're going to calculate my minimum usual value. So I've got my mean, I've got my standard deviation. My minimum usual value is just going to be x bar minus 2 times the standard deviation. So plugging in the values we have here, we get this formula. So take a few moments and go through that. When you finish with that and you've got your own calculations, then move on to the next slide to check it. Okay, here we can see our corrections. So you should have gotten negative 8.7 for your minimum usual value. And now we need to calculate our maximum usual value. Notice it's the exact same formula except we're adding 2 standard deviations, okay? So go through and compute that on your own, and then when you're ready, move to the next slide to check that as well. You should have gotten 951.3 is your maximum usual value. Now, let's take a look at this real quickly and graphing this out to give you a visual representation of what we're talking about. Again, if you're an individual who gets slightly confused with numbers, you're not good at visualizing them, I suggest that you take the extra time to draw things out to be able to understand them clearly. All right, so here we can see the distribution we had previously for our data points with our mean of 471.3. And when we mark on there our minimum usual value, right, and keep in mind now, this is a minimum usual value statistical, so it's not actually practical, obviously, that we would have a dog with a height of negative 8.7 millimeters. So this is a statistical minimum value. And we can see that it is indeed way beyond our lowest value score of 170. Over here on the right, we have our maximum usual data value point that's plus 2 standard deviations, okay, and that's 951.3, and we can see that it is also beyond the range of our highest level of value. So that would tell us, looking at our data set for the height of dogs in our neighborhood, that none of the dogs in this current data set have an unusual height score for this group of dogs in the neighborhood. Keep in mind again, this always has to be qualified by this particular data set. This is not a statement we can make about all dogs in the world or all breeds of dogs or anything like that. We've got to keep it close to what we're talking about. So this statement is simply relating to the dogs in the neighborhood that we have measured. Okay, now we're going to be looking at this again when we look at the empirical rule, which is the next lecture that we're going to be having. So keep this in mind. We're going to come back to this again. This 2 standard deviation points is going to be really important across the semester. All right, our last thing is estimating a value of the standard deviation if we have the range. So if we're if we have the range, we want to make an estimate of what our standard deviation is likely to be, we're simply going to use this formula here. Notice the signs are not an equal sign. They are, in fact, approximation signs. So make sure that you're using that correctly. This is not equal to the standard deviation. It is simply an estimate of the standard deviation. So if we take this and plug in the data that we have, we're going to find that going to get a range estimate of our standard deviation is going to be 172. Now, in this particular situation, our estimate is pretty far off from our actual standard deviation, so it is not a good estimator to be using. This concludes our section looking at calculating the basic measures of variation. Next up, we're going to be looking at the empirical rule.